Hello and welcome everyone. Our today's question is row with maximum ones. So we have given an integer array only containing zeros and ones where each row is sorted. It is important. We have to return the row number that has the most number of ones. If no row exists, we have to return minus 1. So in this case, row number 2 has the maximum number of ones. So we will return 2 in this case. So let's build this approach. So its brute force will be n cross m. I will not talk about that because it is very easy to implement. So let's optimize this. What if I tell you I will make a function for you that will return how many ones are there in the current row. So for this we have 3, for this we have 2, and for this we have 4. And you will create initial maximum number of ones 0 and your answer which denotes the row number. Default value will be -1. So in this case, your ones is greater than maximum ones. So you will increment your ones to this and your answer to the ith row. And in this case, your ones will become 4 and your answer will become 2. At the end, you will return your answer. So now the question remains how we can find how many ones are there in the current row. So we will build a function for this and we will pass the current row. So we have this as our first array. So as you can see, our array is sorted, so we can apply binary search. Our L will point to 0 and R to n minus 1. Then we will find our mid. This is our mid value. We have to find our first position of 1. So we will check, is the mid value 1? Yes, in this case. So this position can be your answer, or your answer will be on the left hand side. So your answer can be this. So our range will be this. So we will point our R to mid. Now find your mid value. This is your mid value. So your mid value is not 1. So the first position of 1 will be on the right hand side. So we have to update our L to mid plus 1. In this case, L and R point to same index. So this is the first position of 1. 0, 1, 2, 3. So our position is 1. First time we have seen 1 on the position index. So we know its length. Its length is n. For maximum, so our number of ones will be n minus position. So 4 minus 1, it is 3. Let's check for another row. So we have this. L points to this index, R points to this index. Mid point to this index. Is this a 1? No, it is not. So the first occurrence of 1 will be on the right hand side. So update your L to mid plus 1. This. So 0, 1, 2 and 3. So 5 by 2 is equal to 2. So this is our mid. Is this a 1? Yes, it is. So our first position of 1 will be your mid value or the left hand side. So we will update our R to mid. R points to this index. So our L and R points to same index. So we will just run out of our while loop and our position is 2 and our number of ones is n minus position, which is 4 minus 2 is equal to 2. So number of ones is 2 here. Let's check for another test, another row. We have this L points to this index, R points to this index. Check for mid. This is our mid value. Is the mid 1? In this case, yes, it is 1. So first occurrence of 1 will be this value, this index, or our left hand side. So we will update our R to mid R. So this is mid now. Is the mid value 1? Yes, it is. So our mid value will be our answer, or our answer will be present on the left hand side. So update your R to mid. This is our L, this is our R. So L and R points to same index. So we can say this is our first position. So position is equal to L, which is equal to 0. So n minus position is the number of ones. So n minus position, 4 minus 0 is equal to 4. In this row, we have 4 rows, 4 ones. So let's code this. We have to find number of ones and our row and n. So we will run for every row, and for every row we have to find how many ones are present in the current row. So this function will return us if the number of ones is greater than the maximum ones. So we have to update our maximum ones to this current row ones, and update our row to ith row, return our row. So now we have to implement our find function. We have given an array. This is the current row array. We have to find the maximum, we have to find the number of rows, or the first position of 1, first position of 1. So initialize your L to 0 and R to n. Run a while loop. Find your mid value. If your mid value is 1, then this is the first position, or your first position will be on the left hand side. So initialize your R to mid, else this is 0. So our 1 will be on the right hand side. So update your L to mid plus 1 at the end. Return the number of ones. So this will return us number of ones. So this solution will work fine. Let's talk about the time complexity. This find function will take log m. So this is the row number, and this is the current row, and its length is m. So for binary search it is long m, and upon that we have n. So its total time complexity is n log m, but it is not expected, it is not meeting the expected time complexity. So let's optimize this further. It is not easy to come up with the solution. So let's first build the approach. We have same array. Let me take an array. We have this array. So in these questions, we can either start from this index or this index. In these types of questions where our array is sorted, but in this particular question, we can only start from this index. I will tell you why. So our I is 0, and our j is m minus 1. So just check, is there 1 present in this index? Yes, it is. So we have to find the maximum number of ones. So go to this index. Is there 1 present in this row? Yes, it is. Is there 1 present in this row? Yes, there is 1 present in this row. So go to next value. Is there a 1 present in this index? No, it is not. So check for next row. So currently our answer, initially our answer is -1, and now our answer points to 0, because till the current row we have seen maximum number of ones, which is 3. We don't have to calculate the number of ones. We have to calculate only the row number. So here row number is 0. So in this index we have seen 0. So check for next row. Check for next row. Is there one present in this row? No, it is not. Check for next row. Is there one present in this row? Yes, it is. So update your answer to current row, because after that there are ones. We can surely say after that there are ones. So we don't have to check after so I plus 1 values, because we have know that array is sorted. So if there one present in this index, so after that there must be all ones. Our answer is 2 in this case. So check for this index. So this index is invalid and we have seen all the ones, and we run out of our loop. So we will just return our answer. So this answer contains the row number. So let's code this. We have n and m and I and j. This point to top right side and our row number. So we have a while loop. As you can see, our I incrementing every time, if not our j decrementing every time. So our range must be valid. So our I must be less than n and our j must be a valid index which is greater than or equal to 0. If there is one present in this index, so this row contains 1. So check how many ones are there. So just move your j value. So the first initialize your r, then move your j value till we seen a ones. So if there is 0, then we run out of this while loop and we have I and j position 0. So we will go to next row. So else there is a 1, so we will go to next row till we are seeing zeros. So if there are zeros, we will just moving to next row number, just moving to next row till we have not seen any 1. So if there is 1, then we will initialize our row number to the ith row, and that's it. And at the end we have to return our row. So let's submit this code. So this solution will submit just fine. My internet is very low at this moment. So there is a similar question on lead code. I will link that question in the description box if you are interested. So thank you all for watching this video. If you still have any doubts, feel free to ask in the comment section.